All right, so here's our last page. And just a couple more examples of using the mean value theorem to first show that there is a slope that you can use that's equal to the average rate of change, and then finding that coordinate point for it. Okay, so let's take a look at this first example. You would go through the same routine that we've been doing. So the first thing you want to do is make sure that your function is continuous and has a derivative that exists. So as I look to see if it's continuous, the domain should work. So we have a cube root and we take square root. So there's no restrictions to the domain because we're squaring everything, which is going to be positive, and then we're taking the cube root of it. So it is continuous. What I don't know is if is it differentiable. So we're going to take the derivative real quick. And so we get 2/3 x to the negative 1/3. So that's 2, and then it's the cube root of x. All right, now we have some issues. There is a value of x where our derivative is undefined. So remember, we have critical values where our slope is 0 or undefined. We don't have a 0 slope here, but we do have an undefined. We're undefined at x equals 0. Now, if x equals 0 is not in our closed interval, then it doesn't matter. But because 0 does fall within our interval of -1 to 1, I can't use the mean value theorem. The reason it is undefined is because there is a cusp at 0. So the mean value theorem does not apply here. All right, so that means we're going to move on to the next one. This one has trigonometry, so you're going to have to remember some of your trig. But I want to do the exact same thing. I want to make sure that first the function is continuous. So we have a polynomial, we have trig, sine is continuous for the whole, well, at least for this interval, plus 1. So it is continuous. That means we want to do a derivative to check to make sure that derivative exists at all points on 0 to pi. So that's 2. Derivative of sine is cosine x plus 1. All right, cosine is defined for all of 0 to pi. So it fits the first condition of being continuous and differentiable. All right, so now what we need to do, also realize we are finding the tangent line. I guess we should always read the directions first. Schaefer, that's bad. So in order to do that, we're going to need a slope and we're going to need a coordinate point. All right, so that will be our goal, is trying to find a slope and a coordinate point on this interval that has the slope that it wants us to find. So what the theorem says, one more time, is there is a slope at a certain point C that is going to be the same as the function at the endpoints. All right, and then we need to find, so we'll find out what our slope is as soon as we do the math, but then we need to find out what the C value is. That C value will be the x that we need for our coordinate point, and so on. All right, so let's go ahead and figure out what slope are we looking at in the first place. So f of pi means plug in pi. So we end up with 2 pi, and then sine pi is 0 plus 1. Minus f of 0, so we get 0 when I times it to 2. Sine of 0 is 0, so we have a 1. So we pi minus 0. And so then we have the 1's cancel out. We get 2 pi over pi, which we get 2. So our slope that we wanted for our tangent line is now 2. Now we need a coordinate point, and the coordinate point is the x value that or the c value that is the position that has the same slope, but also ends up being the x value that we need for our tangent line. So we now know that our derivative is equal to 2, because that's our slope, and we're trying to find the x value that gave us that. So let's do a little bit of math here. Inverse cosine of 0 radians is x. You got to know your unit circle, so we're not down here. When is cosine, as I look at this, when is cosine 0? Well, cosine is only 0 here at pi halves, so that's the answer. That's my x-coordinate up here, pi halves. To figure out my y-coordinate, I'm going to plug it back into the original. So I get 2 times pi halves, which is pi, plus sine of pi. Sine of pi is 0 plus 1. And so my y value is pi plus 1. Now I take all that stuff, that's an arrow, and I write out an equation. Y subtract pi plus 1 equals my slope, 2x minus pi. Okay. And that pretty much finalizes what we're doing. Your homework is just proving that these different values work and where are they working. What I do like about it, and we've written it a couple of times, is the mean value theorem really makes a connection between the instantaneous rate at c and this average rate of change between 2 points. It's basically a secant line. It's very powerful, and there's several examples, especially on free responses. You're looking at a table and you're going to use the mean value theorem to show that a certain slope probably does exist. Okay. All right. Get going on homework, and we can talk about this when you see me on Thursday. All right. Thanks.